Talking about multiplying polynomials today. Multiplying polynomials. This first example, you don't need to write it. The title's good because I'm going to give you a different one in a minute. But let's talk about the basic process of multiplying polynomials. Now, this first example, like I said, you don't have to write this one if you think you already know how to do it. Do you guys know how to multiply this? If you do, then don't write it. You can just watch or ignore me. But if you don't know how to do it, you might want to write it down. So some people like to use foiling. I use a box method. So I put one of the polynomials along the top, I put the other one down the side, and then I fill in the blanks. That's pretty much it. We got 5x squared here, negative 15x there, x here, and then negative 3. And when you do the box method, the like terms are usually, not always, but usually diagonal from each other. So this kind of helps in finding them. And also when you write your final answer, you want to put the terms with the biggest power in front, terms with the smallest power in the back. These two I'm going to combine together. Negative 15 and 1 makes 14, right? Negative 14. And there you go. So that's just a basic example. If you already know how to do that, you're good. But we're going to take it up a notch today to something which I'm sure you've seen this before too, honestly, but this one you might want to write down. It's up to you. What if I gave y'all a problem like this, where I said, now what's x minus 3 times x squared plus 2x minus 5? And once again, I mean, if you know how to do this, and good. If you don't, you might want to write it down. But this is the basic idea. How many terms does this have? And this one? So I need to make a box that's 2 by 3. So it's going to be more like a rectangle this time rather than a square. So the one that has 2 terms, I'm going to put down the side here. The one that has 3 terms, I'm going to write it along the top. And then just fill in the box like normal. Okay? That's the only difference there. So that would be x cubed, 2x squared, negative 5x, negative 3x squared, etc. Once again, like terms are usually, but not always, diagonal from each other. So I've color-coded them there. My biggest power is x cubed. These two green ones can come together. Negative 3 and positive 2 makes a negative 1x squared. Negative 6 and negative 5 makes a negative 11x. And then 15 by itself. And there you go. That's polynomial multiplication. Not too shabby. All right, so I'm going to throw a student practice at you. Just want to do a spot check, see how y'all are doing here. See how you do with that. Get an answer for me?
2x cubed plus 14x squared plus 19x minus 5.
Plus 19x or minus?
Plus 19.
Plus? Okay. And then minus 5? Cool. All right, I think that's right. So if anybody wants to see the process of getting there, I mean, if you're using the box method, this is what it would look like. and then you have your like terms here. So you have 2x cubed, these make 14, these make 19, and that makes -5. I've seen another way to multiply, and which I'll show you in case somebody's still writing that. It's just kind of like old school multiplication, honestly. The only reason why I don't typically teach it this way is because I like to teach factoring and multiplication in the same way with boxes because they go together. This way doesn't really lend itself to factoring very well. But you can just do this like you normally would. So you do 5 times -1, 5 times 4, 5 times 2x squared, and then x times -1. That's negative x, right?
Yep.
And you line up your like terms as you go. So it works just like regular old school multiplication that way. They all work. Okay, so that's basic idea there, but let's move on to some shortcuts because we're gonna expand on this idea of multiplying. But as we do, you're gonna want some shortcuts to make life a little bit easier. So I'm gonna share a couple of shortcuts with you guys. So here we go. Shortcut number 1. If you are multiplying 2 binomials together, and they're the same, but one's a minus, one's a plus, then basically it's just a difference of squares. You guys, it's like the opposite of factoring is what it is. So let's do an example for that. We're on example 3, right?
Yeah.
All right. So let's say I had x minus 5 times x plus 5. So how this works is you multiply the first times the first. What do you get? And you multiply the last times the last. What do you get? And it's going to be minus 25 because 5 times 5, negative 5 times positive 5 is negative 5. You don't need to do the box. You could do the box for this. It'll work. What you're going to find though is that, usually when you do these, you get 3 terms, right? But on this one, you're only going to get 2 terms because if you worked out the box, you'll see that 2 of them cancel out and you're left with just those 2. But the shortcut is basically when you have 2 binomials that are exactly the same except for one's a minus, one's a plus, square the first, square the last, and you got your answer. Let's look at another one there. How about 4x minus 9 times 4x plus 9? What would the first term be? Yep, 16x to the second. So you do this one times that one, right? Yep, you multiply those two, you get 81. It's going to be negative 81. Cool enough? So it's nice to have some shortcuts so you don't have to do the box. But that shortcut only works whenever they're exactly the same, but one has a minus and one has a plus. Now the next one I'm going to share with you, it's not bad, but it's a little bit, it feels a little unfriendly and awkward at first, but once you get used to it, it's good. So first of all, I want to show you guys something, and then I don't want you to write it, I just want you guys to watch. Here's the next shortcut we're going to talk about. What about when you multiply a binomial by itself? Like they're literally the same. Okay? Well, I want to show you what that looks like. I'm going to use the box, but after this I'm not going to use the box anymore. I'm going to show you a shortcut. So, once again, you're not writing this, I just want you guys to observe. So, a times a is a squared, right? A times b is ab, a times b is ab, and b times b is b squared. So you're noticing that you're getting a squared, right? And you're getting b squared, right? What do you get in the middle? You get 2 of those, right? They're identical. Why are they identical? Because you're multiplying identical things. So you get 2ab. And so the shortcut for this one, which I'll write in a minute, but the shortcut for this one is basically square your first term, square your last term, multiply those together, and double it. Does that make sense? I'm going to write it down again. But I just want to share that with you so you guys kind of get the idea a little bit. So we're on part C. We're going to call this shortcut number 2. Shortcut number 2. So if you guys see A plus B times A plus B, the shortcut is this. You multiply, you square the first term, you square the last term, you multiply these together, and double it. Saves you a little bit of time. Okay, now two things I want to share with you before we actually start a problem. Isn't it possible that these are both negative instead?
Yeah.
What that's going to do is it's going to make this one a negative. So you might want to put little minuses there. But it won't change this one. You guys know why? Because this one comes from multiplying this one times this one, and two negatives make a positive. So this one will always be positive on the end. But this sign can be different based on whatever the signs are here. Another note I want you guys to make is, how else can this be written? Instead of saying A plus B times A plus B, we could also write that as this, right? So if you see that, it's the same rule. They both work that way, okay? So if you see this, you're going to use that rule. If you see this, you're going to use that rule. Let's go ahead and bring it to life a little bit. I think we're on example 4 now, right? So let's say I have x plus 5 times x plus 5. Now we know these are identical, right? And when you have the identical ones, you're going to get 3 terms. The first term comes from squaring the first term. So if I square the first term, I get x squared. The last term comes from squaring the last term, which gives me 25x. I'm sorry, just 25, not 25x. The middle term comes from multiplying these together and doubling it. What would that give me? 5x, 5 times x, and then double it. What would that give me?
10x.
10x. This one is always positive. This one will be whatever these signs are. What's the signs? They're positive. So there's your final answer. Okay? Let's do another one. X minus 3 squared. X minus 3 squared. Now x minus 3 squared, that just means x minus 3 times x minus 3, right? So we have our shortcut again. What's my first term going to be?
X squared.
What's my last term going to be?
9. Positive.
Good. What's the middle going to be? Close. Negative 6x. So remember, this is like this, right? You multiply these, that's negative 3x, but then you double it. So you get negative 6x. Let's do one more. I'm going to give you 4x minus 7 squared. 4x minus 7 squared. 3 terms. What's the first term going to be? Last term?
49.
Good. All right, take a minute, see if you can figure out the middle. Don't shout it out yet. I just want to give people a chance to see if they can figure that out. It's going to take a minute. So we're going to multiply 4x with 7. And then we're going to double it. So 8 times 7 would be 56. Yes, and the sign will be negative because this one's negative. And there's your shortcut. Once again, the box will work, but the point of this is to give you guys a shortcut. Okay? So I'm going to throw up a couple problems for you, but I've shown you guys two shortcuts, okay? I've shown you this one where they're exactly the same, or it could be written as a square. I've also shown you this shortcut where they're almost the same, just one's a plus and one's a minus. So don't get the rules mixed up. But there you go. So I'll throw a couple at you here. Student practice 2. Okay. Show me what you got. So John Herrera, what did you get for first one?
No.
Are you getting help right now, or are you helping somebody? Okay, I'll let you keep working. Go ahead. Okay, I'll come to you for second one. Talia, what'd you get for the first one?
I got 9x to the second power minus 75x.
Is that no, I wanted number 2. Oh no, I'm sorry. I did want number 1. What did you get?
9x to the second power minus 75x.
Okay. And
Plus 25.
I agree with your first and last. Your middle one, I'm not quite. How did you get? You're not.
I don't
So
know how I got that number.
you're not sure?
I messed it up.
Okay. So what we do here, Talia, is we multiply the first and last terms
I
together.
know how to get it. I just messed it up.
Oh, okay. So that would be 15 times 2, which is 30.
Yeah.
And then it will be minus 30x. Jonathan, what did you get for number 2, bud?
I got 4x squared minus 1.
That is correct. So I'll give you guys trying to apply the shortcut number 2 to this one. Shortcut number 2 is the one where they're exactly the same. This is a shortcut 1 rule where they're almost the same, just they have different signs. So make sure you're applying the right shortcut rule there. And Tristan, what did you get for the last one there? That's right. So this is the shortcut number 2. Square the first, square the last, multiply your terms together, x times 6, and then double it, and you get 12. All right. So that's shortcuts. Now we're going to put everything together. So what letter would you really leave off on? D?
C.
We're on C now? We're on D. Okay. So let's talk about multiplying in general then. Multiplying in general. So I'm going to give you guys some steps to go through that will kind of guide you through pretty much every problem. The first thing you want to do is you want to make sure you do your shortcuts. So if you got any shortcuts to apply, go for it. Do the shortcuts. After that, if you can, do the box. Sometimes you're going to have a single number or a letter or something on the outside. We'll do that at the end. That's just basically a simple distribution problem. So I'm going to give you an example that has all 3 of these in it, but just understand, some problems are just shortcuts. Some problems are just box. Some will be just the first 2 steps. Some will be the first and third step. The point is that if, start at the top and work your way down. If you don't have a shortcut, then move to number 2. If you don't have a box, move to number 3, etc. But that's kind of as bad as it gets. So I'm going to give you one that has everything in it, and then we'll see how everything pans out. So, you guys got that? Can I proceed? Okay, so let's do an example. I'm on example what now?
5.
5. Okay. So let's say that I had 2x times x minus 1 times x plus 1 times x plus 3 squared. Yeah. Got a little bit of work to do here, but now we know some shortcuts, so that makes life a little bit easier. Do you guys see the shortcuts? There's two of them in there.
X minus 1.
There's one, and then
The x plus 3 is
good. So here's what I want you to do. I'm going to pause for a second. I'm going to let you guys figure out those two. Go ahead and figure out what goes in those parentheses. Do the shortcut. So what's the first one going to turn into? It's going to be x squared minus 1. Right? Square the first term, square the last, put a minus between them. This one, square the first term, square the last, then multiply those together and double it. There we go. Okay, so what do we do after we do the shortcuts?
box.
You do your box. And now I'm going to do the box on this stuff right here. I'm going to have a 2 by 3 box again, right? So we have x squared minus 1, and we have x squared plus 6x plus 9. And when I'm all done, I'm going to have something in here. And then that 2x is still in the front. We don't want to forget about that. Okay, so let's do it. x4, etc. Okay, now, got to watch out for your like terms here. They're kind of not where they usually are. This one is like which one? It's like the 9 over here, right? So we're going to combine those. And you always start with the biggest power. What's the biggest power? So let's put that. I'm going to cross it off as I go. What's the next biggest power? There's no like terms for that, so that much as is. Then we're going to put these two green ones together. What's that going to be? Positive 8x squared, yeah. And then the other two come out. So, shortcuts, box, last step, just distribute. So, and once again, you're not always going to do all these steps, but in this case, we are. If you have just a little number sitting out in the front here, you're just going to go ahead and multiply it in and see what you get. So this is going to give me 2x to the 5th plus 12x to the 4th plus 16x to the 3rd minus 12x squared minus 18x. Yeah, it's just a bunch of multiplying and adding. So you might wonder why we're going to do this. Well, I think our crowning achievement in this chapter is going to be to get you guys to be able to graph a polynomial. Usually what you need to do that is you need to be able to factor it and break it apart so it looks like this. So why are we working backwards and put them together? Well, sometimes you do need to write your polynomials in standard form. I'm actually going to give you some problems where they're already in factored form, and having it in this form kind of helps you know some things about it. But we'll get to that later. But for now, that's why we're learning it. So we start with the factored form and we end up with a standard form. So once again, your steps are shortcut, box, distribute, and you're not always going to have to do every step. Okay? Let's throw a student practice at you and see how you do with it. Dylan, Lee Bryant, were you with us on this one? No? Okay. The other Dylan? Sure, go ahead, Dylan. So what's this become other Dylan.
That one, okay. 9x squared minus 12x plus 4.
9x squared minus 12x plus 4.
Yep.
Square the first term, square the last term, multiply those together, you get 6, and then double it. So you get 12, the sign matches with minus 12. All right, and then after that, we're going to do the box method, right? And so if we do the box method here, I forget what we get. Ishmael, did you get a chance to fix yours yet? Did you get a chance to fix your box yet, Ish? What did you get after that? Uh-huh. Hey, okay. Okay, I think that's right. If you want to see the box, I can show you. But kind of tiny, sorry. Not much space. So you have 9x cubed. Negative 12 and positive 9 makes negative 3. Negative 12 and positive 4 makes negative 8. And then 4 comes out as is. And then after that, we distribute the negative 3 in. Taekwon, what was our final answer on that then?
Negative 27 x to the 4th.
Uh-huh.
9x cubed plus 4x squared minus 12.
Okay. Minus 12x, right? Okay. So that's it. Now, the next one I kind of threw at you guys is just kind of like a, yeah. So first of all, we don't have a shortcut for this. There is a shortcut for that, and I'm not going to have time to show you today. It's not a big deal. I showed first period, and I kind of regret that because it's not that important, and then they didn't get as much time to practice this stuff, which is important. So, but I might make an extra credit lesson where I show you shortcuts for any power. Get that posted up. But anyway, here's how this one would work. The way you deal with it is split it up, right? In which case you get a shortcut, right?
Yes. Oh, I'm so stupid.
Once you have that, all you have to do is the box.
I told you. I'm stupid, Mr. Bailey. I told you to say that. I'm stupid, Mr. Bailey. I'm sorry.
No, you're
Exactly
not
what I got.
stupid.
I'm sorry, Mr. Bailey. I failed you.
So that's that, guys. We're gonna call it quits there for the day. Hey, Seth.
I told you.
Oh, you're right, Seth. Yes, that is an x cubed minus 3x squared. Good. Yeah, thank you. All right.